Welcome to Spring LIB.
All right, so let's take a look at a generic single displacement reaction where we have an element and a compound to see if a reaction will occur. So A here and B are substances that can be cations. So we're going to see whether this element can become a cation or not. We have to compare A and B and see which one is higher on the activity series. So if A is higher on the activity series than B, there will be a reaction. If B is higher than A on the activity series, there's no reaction. All right, so let's take a look at some examples of that. So for instance, if we were to look at iron metal, so iron metal is solid, and if we were to react that with copper 2 nitrate, so CuNO3 2. Now what we need to do is compare where iron and copper, that's our A and B, compare where they are on the activity series. Iron is higher than copper. A is higher than B. That means a reaction will take place. And so when the reaction takes place, the iron and the copper switch places. So the copper is now going to be all by itself, and the iron will now be with the nitrate. And nitrates are soluble, so that's going to be an aqueous substance. And the equation, as is now here, is balanced. Now we can take a look at some other examples. We can take a look at zinc, solid, wanting to try to react with magnesium sulfate. So we're going to compare where Zn and Mg is on the activity series. So Zn is lower than Mg on the activity series. So put the other way, magnesium's higher than zinc, B is higher than A, no reaction. So we don't have to do anything other than to write no reaction. That won't happen. We can take a look at tin plus hydrobromic acid, HBr. So we have to compare Sn and H, tin and hydrogen. Tin is higher. So we are going to form hydrogen gas, because when we swap, the H is going to be by itself. But remember, hydrogen doesn't come as H, it's a diatomic element. It always comes as H2 and as a gas. And tin here, we're not sure which type of tin it's going to make, but to make because it could be either tin plus 2 or tin plus 4. But to make our life a little easier here, let's make it tin 2 bromide, which is aqueous, and then we can balance the equation by putting a 2 in front of the HBr. So again, if the element is higher than the cation in the compound, the reaction takes place. And finally, if we take a look at aluminum metal, metal is just a solid, and we react that with cobalt 2 sulfate. Now the question is the aluminum higher or is the cobalt higher? And the aluminum is higher. So we're going to go ahead and do this reaction. And so the aluminum and the cobalt will switch places. The cobalt will now be by itself. The aluminum goes with the sulfate. And just make sure you balance out charge. Aluminum is +3, sulfate is -2. So to balance out the charge, we need 2 aluminums and 3 sulfates. And I just noticed here that that is actually not D, but E. So let me go back and take a look at D. And so for D, we're going to take hydrogen gas. Remember, hydrogen gas is H2. And we're going to react that with nickel 2 chloride, which is NiCl2. So is hydrogen higher on the list? No. Nickel is higher. So the reaction's not going to happen. No reaction. So the bottom line is, if the element by itself is higher than the substance in the compound, the reaction will take place. If the substance in the compound is higher on the activity series than the element by itself, there's no reaction.